Hi, Bronx Arts middle 7th graders. This is Mrs. Cotton here, and I am going to guest teach the 7th grade math lesson for today. All right, here we go. So before we left the school building, we had taken 3 different assessments. We had taken 2 ANETs and then 1 mock math assessment that was similar to what you guys would have seen if we had had a state test this year. So one of the things that we noticed is that in expressions and equations, we have a lot of work to do. So you'll notice that it lists out the different standards that relate to expressions and equations, and then what the proficiency rating, right? So when you guys sat down to take the test, only 29% of those questions that were aligned to that standard were answered correctly. So the one that we're going to start focusing on today is 7EEA1, which says that we can use properties of operations to generate equivalent expressions. Specifically, what we're going to work on today is applying properties of operations to add and subtract. So the first thing I want to do is go over the objective. So the goal for the end of this lesson and the meat is that you guys will be able to create equivalent expressions with rational coefficients by combining like terms. Before we jump in and get too far ahead of ourselves, I want to talk about the parts of an algebraic expression. You guys have been working on this in 6th grade, so this is nothing new, just a quick reminder. So there's a couple different things that we need to notice when we attack an expression. The first thing is what a constant is. So you'll notice in this case, we have a constant term labeled for the numerical term 7. So constant terms essentially is their value is constant. They don't change. And so anytime we see a number by itself not multiplied by a variable, we know that it's a constant. Operation symbols are really important when we're working with expressions, and we'll see why they're so important as we move into an example. But in this case, we want to look for the plus and negative signs, right? So the addition and subtraction symbols. Coefficients and variables, super, super, super important. So a coefficient is the number that's in front of the variable. So it's any number that's being multiplied by a variable. Variables just represent unknowns. We see them as letters. We don't know what the value is, so we use the variable as a stand-in. Okay, so let's jump into a first example. So think back to some of your earliest math. We spent a lot of time adding and subtracting and counting fruit, right? Apples and oranges. And we knew if we were being asked how many apples, we couldn't include oranges in the count because they're just not the same thing. And while the math has gotten a lot more complex, the same concept holds true when we're working with variables. So in this expression, we see that we have 3x plus 2y plus x plus 3. We have x's, we have y's. We can think of them just the way we would think about fruit. Apples and oranges are not the same thing. So we have to be really mindful of our variables. So let's take a look at what this would look like if we represented it visually. I drew it out for you here. You'll see that we have 3 x's that we're adding to 2 y's plus another x plus a 3, right? So we have a term that has x as a variable. We have an algebraic term with y variable. And then we have another term that has the x. It's really important to remember that when you see a variable that doesn't appear to have a coefficient in front of it, it does have a coefficient. It's represented by 1. So we don't need to write 1x and its proper form to not write the 1. But when we're combining like terms, it's a good habit to get into to write it just as a reminder to yourself of what number is actually there. So there's a couple steps that we want to follow when we're creating equivalent expressions by combining like terms. The first thing that we're going to do when we attack an expression like this is we are going to annotate the expression. So what does that look like? I like to do it using different shapes to sort of bubble in the letters. So the first thing I do is I look and I see that I have a coefficient of 3 and I have a variable of x. Because I have an x, I'm going to go ahead and box this in. Then I notice I have a plus y, 2y. Because this is a different variable, I need to represent that using either a different color or a different shape, or in this case, I'm going to do both. What's really, really important to remember here is we have to include the operation symbol in our little bubble so that when we start moving things around, we don't forget about it. My next term is that x, right, with the coefficient of 1. I'm going to go ahead and box that, just like I boxed my other algebraic term with the x as the variable. And then finally, I have a constant, right? That's my 3 sitting out here. And I'm going to go ahead and just draw a little cloud around my 3 and making sure to include my operation symbols as I'm annotating. So the next thing that we're going to go ahead and do is we're going to rewrite the expression and group the like terms. And we know from earlier years when we talked about the commutative, I have so much trouble with that every single time, commutative property that we can move these terms around without changing the value of the expression. So I'm going to start by grouping all of my x's. So I'm going to bring my 3x down. I'm going to go ahead and cross it off so that I know that I've included it here, because as we get to longer expressions, we sometimes miss terms. So then I know I need to add my next x, so plus 1x. Go ahead and cross it off. Then I'm going to go ahead and add my 2y, cross it off. And then I'm going to go ahead and add my constant, cross it off. So the final step is I go ahead and simplify. 3 plus 1 is 4x. I don't have any like terms with a y, so that remains the same, plus my constant. So I know, now that I've simplified, 4x plus 2y equals 3 is the same as my expression up here. These are equivalent expressions. And I can go ahead and just write that in, just so I know that these are the same, and this is my simplified expression. Okay, let's take a look at another one. So example 2 is x minus 2y minus 3x plus 6. Same thing, right? I made sure to create a visual model for myself, and I included the coefficient of 1 just so that I make sure that I do the right thing with my math. And then I subtracted 2y, subtracted 3x, plus 6. So again, I'm going to annotate to identify my like terms. I'm going to go ahead, once again, I'll box my x. I'm going to circle my negative 2y, or my operation symbol, my subtraction symbol. Minus 3x, again, making sure to include that operation symbol because that operation symbol needs to move with it. And then finally, I'll bubble in my final term, which is plus x, making sure to include the operation symbol. So same thing, following the same steps. I'm going to rewrite grouping with my like terms using the commutative property. Commutative property. So x minus 3x minus 2y plus 6. So now I have, you'll see, my x's grouped together. I'm going to go ahead and write in my 1 as my coefficient as a reminder. So now I have 1x minus 3x. So 1 minus 3, because my negative 3x has a higher value, I know that I'm going to end up with a negative. And 1 minus 3, negative 2x minus 2y plus 6.